All right, algebra, here we go. We're in section 2.8 now, talking about two variable inequalities. We're just going to combine some of the graphing stuff that we've already done, and then we're going to look at it with inequalities, where you graph the lines the same way you've been doing it, and then we're going to shade up or down, one side or the other. Our essential question is graphing an inequality in two variables similar to graphing a line. The answer to that is going to be yes. You're going to graph whether it's a line or an absolute value. We're going to graph them the same way we've been graphing them. Okay? Graph the line or absolute value the same as we have been. And the addition is we're going to shade. Okay? When you graph a line or that absolute value, the values that make the statement true or your equation true are the points on that absolute value or that straight line. Okay? That's what those lines represent. All the solutions to that equation. You can take any point off the line, x, y, plug them into the equation, and you'll get a true statement. Okay? When you're talking about inequalities, it's not just points on the line, it's one side or the other. One side of that line could have, all of those will give you true statements. And then the other side, everyone would be false. You might plug in a point 1, 2, and you get something like 5 equals 5. And every point on that side will give you a true statement like that. And the other side might turn out to be 0 equals 6, which we know is false. So we know that side is the wrong side, doesn't have the solutions. If your inequality is greater than or less than, remember you're going to get a dashed line. Okay? We get a dashed line out of that. If we get y is greater than or equal to, or y is less than or equal to, we're going to graph solid lines. Okay? Very similar to the number line where we had a dot if it was included, if there was an equal. And it was a circle if it wasn't. Remember, the circle meant you couldn't use that point. Same thing with the line. That means you can't take a point off the line, whereas here you can. Okay, let's look at some examples. Again, this should be review for us, because we've been graphing these guys. Y is greater than or equal to 3x minus 1. Okay, here's our slope. Here's our y-intercept. Remember, we plot the y-intercept, so we go to -1, we put a dot. Our slope is 3, which can be written as 3 over 1. So from our y-intercept, up 1, 2, 3 over 1. There's our second dot. You notice my inequality does not have an equal sign to it, so I have to graph a dashed line. But my y is greater than. Where are the bigger y's at? They're up here. So we shade this way. When you got an inequality problem, you must shade. If you don't shade, it's wrong. Got to have it. Okay, that's the whole idea of it. That means that all the solutions to this are up here. I can take the point 0, 0. Is 0 greater than 0 minus 1? Is 0 greater than -1? Sure is. I could take the point 0, 3. Is 3 greater than or equal to 0 minus 1? Sure is. Take a point over here, like 4, 0. Is 0 greater than 12 minus 1? Nope, 0 is not greater than 11. So what we're showing is that all the solutions are here, and all the points on the other side will give you false statements. Okay? And you cannot take a point off the line because those are going to end up being equal, and there's no equal here. So we can't do that. Here we have an absolute value, which we've been graphing here. We got to get it in the y equal, so we're going to subtract our 1 here first. You don't want to subtract in here, you can't get inside there with that, so it stays outside here. So you end up now with -y is less than or equal to the absolute value of x plus 2 minus our 1. Then you're going to divide this thing through by the -1 there, because we want a positive. What do you have to do when you multiply or divide by a negative? Don't forget to flip your inequality symbol. Okay? Real important right here. This has got to change. Okay, I'm going to put my negative out front, and that becomes a +1. Okay, remember what we just talked about. This moves it up 1. This is going to go to the left 2, to -2. Okay, so from the origin, I'm going to go up 1. I'm going to go to left 2. There's my vertex. I've got a negative. So I'm going to shade down. I've got an equal, so my V is going to go down with solid lines. Okay? But my Y is greater than. Where are the bigger Y's at? Up here. Because these are all clearly smaller Y's. So that's how you do that. one here without the equal, so we dashed it, shaded up because it was y was greater than. Here you divided by the negative. Once you solve for y, we had to divide by a -1, so you got to flip your inequality symbol. So now y is greater than or equal to, and because it's equal to, I had a solid line here. I moved my vertex up 1, I went to the left 2, and I had to open it down because I had a -a value there. So there we go. Any number up here like 0, 0, 1 minus 0 is 0, 0 plus 2 is 2, 2 minus 1 is 1. Is 0 less than or equal to 1? Yes. Okay, so you can see all the true answers are up top here. Okay, hopefully that's been helpful. When you come in here tomorrow, we'll look at graphing some of these, we'll look at a little application of it, and you know, you can see we're getting towards the end of the section here, so we're getting ready for the chapter test the following week. But we're going to spend a little time here with the graphing and hopefully tying together some of the things we've been doing here this last week. All right, make sure you get these notes down. Any questions, let's get them answered tomorrow. Come in here tomorrow ready to work. See you then. Have a good one. Bye.